All right, so now let's look at example 2. In 1990, the population of California was 29,816,591. It is growing at a rate of blank percent each year, and we want to determine the change factor given P of t equals 29,816,591 times 1.0128 raised to the t power. So we're first going to identify the change factor, okay, which again is our B, what we've been looking at since the beginning of the semester. It's always in front of our variable exponent. So 1.0128 is my growth factor. So I'm going to take that growth factor and I'm going to use it to find my change rate. So that's the absolute value of 1.0128 minus 1. And again, we're taking the absolute value. So 1.0128 minus 1 is actually the absolute value of 0.0128. And the absolute value of that is 0.0128. I'm going to change my change rate to 8%. So I'm going to move the decimal 2 places to the right. So I get 1.28%. So our population is growing at 1.28%. Okay. So now let's go estimate the value after 4 years. Okay. And what we have to realize is if I'm starting with 29,816,591, okay, and this is a growth rate because it's increasing, I have to have a number greater than that. So when I go to plug in, because I'm looking at function notation, P of 4, wherever I see a T, I'm plugging in a 4. Okay, so I'm going to have 29,816,591 times 1.0128 raised to the 4th power. So let's go plug that into the calculator. And again, it's got to be a number greater than that initial 29,816,591 times 1.0128 raised to the 4th power. And we get, okay, oh, here's a great thing. People, we have to round, so we can't have any decimals, okay? So, and we also don't want to round up because we can't just automatically make a person. So we round down with people or living things, animals. Okay, so we're going to have 31,372,762. So can I remember this number? So 31,372,762. And that equals P of 4. So in the 4th year, the population is going to increase to 31,372,762.